So you've collected some data, and now you want to show it off to the public so that they can understand the results of what it was you were doing. Well, what better way to do that than by creating what's called a scatter plot? That's what we're going to do in this clip. I'll show you how to make a scatter plot on the left with an example, and then at the end of the clip, I'll get you to try your own problem, and you can make a scatter plot yourself. So let's have a look at the first problem that I'm going to solve. The stopping distance of a car has been recorded below. And in A, create a scatter plot. And then in B, we're going to look at the scatter plot and ask ourselves, is there a trend? Do we see anything? And we've been given the results of the study in a table that looks like this, where the first row is the speed of the car, and the second row is the stopping distance in meters. So we have a bunch of points, basically, or ordered pairs that go together. So we need to put those on a scatter plot first in A. Let's get started. Like most graphs, a scatter plot requires that we make an x and a y axis. So let's make those first. Here's our x-axis, and it has an arrow on the end to show that it continues on. And we have a y-axis that goes up, and it has an arrow also to show it continues on. The first row, the speed of the car, that will be our x-axis down on the bottom. Now, we need to figure out how many intervals to make on the x-axis. Well, if you look at these numbers, it looks like they range anywhere from 20 up to 110, and they seem to go up roughly 10-ish every time. So I'm going to divide the x-axis up into 10 sections. And I'm going to do my best to try and make each section equal. So there's my first dash. I'll have a second dash there, a third dash there, fourth, and then we'll just continue that trend. There's my dash marks. Now I can start numbering them from 10 all the way up to 110. And they go up by 10 each time. So there's 20, there's 30, and so on. There we go. Final thing I need to do for the x-axis is to let the reader know what I'm showing here on the x-axis. Well, it's the speed of the car in kilometers per hour. So let's just add a title to the axis. Speed. And always put your units. I'm going to put kilometers per hour. And our x-axis is now done. So let's do the same now for the y-axis. It's going to be the stopping distance. How many intervals should we have there? Well, it looks like roughly the same. We can go up by 10 pretty safely and fill in all the values. So let's do that. We'll have 10 dash marks, just like on the y or the x-axis, that are spaced out nice and even. So there's 3, and I'll just continue that. And now we can start numbering the dashes, just like on the x-axis. So the first one's 10, then 20, yep, then 30, and then we'll just complete the rest. There we go, from 10 to 110. Now we need a title for the y-axis, and it's the stopping distance in meters. And since I'm running out of room, I'll just put SD for stopping distance, and my units, of course, are meters. There we go. Now comes the fun part. We start actually plotting our points on the scatter plot. So the very first point has an x value of 25 and a y value of 10. Let's go back to the graph and we'll find 25 right about here on the x-axis, or the speed, and the stopping distance is 10. So I go up until I've reached 10 on the y-axis, and I draw my first point like that. Then I'm going to do the next point. It has an x value of 35 and a y value of 15. 35 is right here, and I go up to 15, which is right in between that 10 and 20, and there's my second point. The third one will be 45 and 21. 45 is right about here, and 21, we'll say roughly right there. Now let's just fill in the rest of the points. And there you have it. There's all our data points labeled on the scatter plot. Now the very last thing we should do is add a title so that anybody looking at our graph knows exactly what we're showing. We'll add a title right up here. We'll just call the graph stopping distance versus speed. So now in B we're asked, is there a trend? Let's have a look at the dots. You can see right off the bat there's definitely some kind of trend. The line is going uphill, so it's a positive slope. And we can show that with an arrow, just like this. If I draw this arrow and I try and match the dots as best I can, it's probably going to look something like that. So we're definitely going uphill. But you'll notice it's not perfectly linear. When I tried to draw a line, I couldn't connect all the dots. You see there's a curve to all of our dots. So it's not exactly linear. And that's because the faster your car is going, the longer it takes to stop. So we have a positive trend that is non-linear. And there's how we make a scatter plot. Let's get you to practice your own scatter plot now with your example. The attendance at a school hockey game has been recorded below. A, create a scatter plot, and B, is there a trend? And here is your table of values. You can see we've got the games in the first row and the attendance at each one of those games in the second row. So, using the steps I showed you on the left, try and make a scatter plot. Don't forget your titles and make sure that you have games on your x-axis and attendance on the y-axis. And I'll show you the graph when you're ready. All right, here's our scatter plot for the hockey attendance at this school. We can see that there is some sort of a trend. It looks like attendance has been dropping off. I guess the team is on a real bad losing streak, and less people seem to be going to each game, except for Game 3. Maybe it was a really good matchup. Game 3 had more people than Game 2. But if you eliminated Game 3 and just didn't pay attention to that dot, it's a definite strong negative trend going downwards. So to answer B, yes, there is a trend, and it's negative. Keep in mind we had a title. Game is on the x-axis, attendance is on the y-axis, and we had a main title. And the interval for games was just 1, and we chose an interval of 20 for attendance.